Okay, the title of our notes is Graphing Cosecant and Secant functions. And we're going to do this through our understanding of graphing sine and cosine. So we've already looked at and understand quite a bit about graphing sine and cosine. And with that in mind, and understanding that the secant is the reciprocal of cosine, cosecant is the reciprocal of sine, and the secant is the reciprocal of cosine. We're gonna go through with these graphs, okay? So the sine function. We know the general shape of this is we're going to work with the positive sine function. If I do 2 periods of this, okay, there's the first period of that sine function. We know the period's 2 pi. And I'll do one more period of that. So we'd be all the way out to 4 pi. Okay. And we know it reaches a height of 1 and a depth of -1. Okay, so its max is 1, min's -1. So if we start taking these y values and find the reciprocals of them, we'll start creating what the cosecant function. A good place to start is at the x-intercepts. Okay, at the x-intercepts, what's our y value for the sine? 0. And what's the reciprocal of 0? Undefined. And often the way undefined shows up in graphs is it doesn't show up. It just, your graph approaches that point and either goes up to positive infinity or goes down to negative infinity. And so it's like this invisible wall that it can't pass through. And we call these vertical asymptotes. And so what I'm going to do, this is not part of the graph, but I'm going to put that invisible wall there at all these points, because we're undefined at those points. Okay, then the next easiest spot to look at is the max and the min. Okay, what's the maximum value, maximum y value? 1. What's the reciprocal of 1? 1. So we know they share a point there. And also here at 1. How about -1? What's the reciprocal of -1? -1. So the max and min of the sine function is actually part of the secant function. Sorry, cosecant function. Okay, then what do you know? Okay, this is in terms of y values, right? As our y values go from 1 to 0, get closer and closer to 0, what happens to the reciprocals? They get larger and larger and larger, approaching infinity. So this thing is going to get larger and larger and larger, approaching infinity both ways. And this happens the same way, but towards negative infinity, towards positive infinity, and so on. Okay, so the part that I'm going to highlight here is the cosecant function. Right, and this is 2 periods of that cosecant function. One period would be the first happy face and the first sad face, right? That's one period, and then it repeats itself. So that's the pattern. Okay, and so I'm going to, right below this, y equals cosecant x, and I'll highlight it with the same highlight to show you, okay, we got a couple graphs on here. The highlighted one is the cosecant one. The one in black ink is the sine. And there's a relationship between them. They're reciprocals of each other. And so when you graph the cosecant function, you're going to want to start with the sine function as a helper graph. And then your choice, you could pull out that eraser and erase that sine function at the end. Leave it like that. Or maybe you want to leave it on there and you could just dash it to say, okay, this is really not my curve. This is just a helper graph. You do that. Or you may want to just use different colors and highlight the one that we end up with. Okay. But it's important that you know everything that's dashed on here is just me helping me graph the real cosecant function. Okay. Let's look at cosine in the same way. And again, we'll do 2 periods of cosine. And then its reciprocal, the secant. So y equals cosine. I'm going to dash this one now because this is not my goal. The goal is to get the secant. Okay, there's 1 period at 2 pi here. And there's 2 periods of the cosine function. We know it reaches a height, a max at 1, a depth at -1. And we can do the same exact thing we did with sine. Same reasoning. We start with those x-intercepts because that's when we have y values of 0, and the reciprocals of 0 are undefined. So wherever there's an x-intercept, I'm putting a invisible boundary line. We call it a vertical asymptote. Okay. And then wherever there's a max or a min on the cosine function, I'm going to put a point because that's part of our reciprocal function, which is the secant function. And then as our graph gets closer and closer to that boundary line, it gets higher and higher to infinity, or if it's below the x-axis, it'll go down to -infinity, forming this shape. Okay, and so what we have here now is 2 periods of the cosine function. And what I'm highlighting in yellow is the first period, and what I'm highlighting in green is the second period. Okay. All right, so let's look at some examples now of these graphs. Okay, so example 1. We're going to graph y equals -1/2 cosecant of 3x for x between -2 pi over 3 and pi over 3. Okay. So the first thing we need to do is start with our helper graph. And our helper graph is the reciprocal of this, which would be y equals -1/2 sine of 3x. And graph everything that we've learned with the sine of 3x. Put all those points on the x-axis, all those critical points on the y-axis as well. Get all that whole shape in there. Once that's all built in there, then we just draw in the reciprocal and everything else is easy. Okay, So the hard work is actually just the helper function. And I want to graph from negative 2 pi over 3 to pi over 3. Not sure kind of where that starts or ends yet. And so I'm just gonna do one period right now of the sine function. And put everything that I know for that one. And I know it's going to reach a height of what? Positive 1/2 and a depth of negative 1/2. That comes from the amplitude. The period of this function is 2 pi over b, where b is 3. So 2 pi over 3. And we break that period into fourths. So I'm going to divide that by fourth, or I'm going to find 1/4 of 2 pi over 3 by multiplying that, and you get 2 pi over 12, which is pi over 6. Okay? So my critical points happen at my x-intercepts, my min, my max, and this is pi over 6, 2 pi over 6. And as I'm putting these numbers on the x-axis, I'm keeping an eye out for how far do I want to go? I want to go all the way to pi over 3. Have I made it? Yeah. So 2 pi over 6 is pi over 3. So I actually need to pull out my eraser and say I don't need this part of the graph here. Okay. But now I need to go backwards pi over 6. I need to keep moving backwards. So maybe mark this off as well. So negative pi over 6, negative 2 pi over 6. I'm going to keep going until I get to negative 2 pi over 3. So you guys stop me when I get there. Negative 3 pi over 6, negative 4 pi over 6. Stop. Okay, because if you reduce negative 4 pi over 6, you get negative 2 pi over 3. And so if I keep this pattern going, it's going to go up to its max, back down to an x-intercept, down to its min, back up to its x-intercept. Okay. So I have a sketch of y equals negative 1/2 sine of 3x, going from negative 2 pi over 3 to pi over 3. So now I'm ready for the reciprocal function. Put the boundary lines wherever you have an x-intercept. Put a point wherever there's a min or a max. And from that point, approach those vertical asymptotes, moving either to positive infinity if you're on the positive side, or negative infinity if you're on the negative side. And our answer is what I'm highlighting. This is the graph we were after. Okay, so for our next graph, I'd like you to graph y equals 3 times the secant of x for x between negative 3 pi over 2 and pi. Okay. So whenever you have that secant or cosecant, you always use your helper graph first. Start with the reciprocal. So we're gonna, what's the reciprocal of this? Y equals 3 cosine x. Do everything you can with that one, and then go ahead and do the secant. I'll give you a couple minutes to work ahead here. All right, so on this one, if I go one period of that cosine function, it's a positive cosine function, so I start high at its max, drop down to the x-intercept, to its min, and back at its max. Okay, that's one period of that cosine function. The period of this function is 2 pi over b. b in our case is 1, so it's just 2 pi. And if I cut that into fourths, 2 pi over 4 is going to give me pi over 2. So I'm counting by, this is pi over 2 here. This is 2 pi over 2, which is pi, and that's as far right as we want to go. I'll leave the full period there. I'll just erase it in a second, okay? Now we want to go back, and I'm counting pi over 2, so negative pi over 2, negative 2 pi over 2, one more, negative 3 pi over 2, and that's as far left as we want to go. So it's the x-intercept, gets to its max, goes back to the x-intercept, and just so I don't forget, I'm going to erase what I don't want. Okay, so that's the helper part. Wherever there's an x-intercept, put a vertical asymptote. Wherever there's a minimum or a maximum, put a point. Sorry, this should be right here, huh? My graph is off a little bit. And then make that graph approach either positive infinity if it's above the x-axis or negative infinity as it gets closer to the boundary lines. So what I'm highlighting here is our answer. And there we go.